One of the most important properties, and that word property, you'll understand it better next lecture. One of the most important properties of matter is its density. What do I mean by density? First of all, look at this picture. You have a styrofoam brick and you have a brick, and they are the exact same volume. They're taking up the same amount of space, same length and width and height. But notice that the brick has more mass. Why? Well, you might think that the brick particles weigh more than the styrofoam molecules, but you would be wrong. The styrofoam molecules weigh more than the brick molecule. So why does the brick molecule or the brick, why does it weigh more? Well, if you were to look at it under the microscope, you would find that the brick molecules are closer together. They are very close together. So even though the little white molecules on the left are heavier, the fact is these guys on the right can hold more stuff. The molecules are closer together, so there is overall more mass on the right than there is on the left. On the left, you have a lot of empty space. So how much matter can exist in a space? That is its density. That is its density. So what is density? How much stuff or mass is crammed in a particular amount or volume of matter? It is, in essence, mass per volume, or mass divided by volume. And the units that we will use are going to be grams divided by milliliters. Grams divided by milliliters. Every substance, whether it's a compound or an element, will have its own particular density, such as oxygen, with a density of, as you can imagine, oxygen molecules, that's in air. These gas particles are going to be really, really far apart, so their density is not going to be that much. Water has a density of 1.00. So once again, water is very, very strange. Compared to molecules that are like water, water is actually pretty dense. Ice is less dense than water. That is really, really strange. Most of the time, the solid phase is more dense than its liquid phase. And by most, I mean 99.99999999999%. There are only a few compounds in all the universe where its liquid phase is more dense than its solid phase. Ethanol is a little bit less dense than water. Aluminum is about 3 times more dense than water. Iron is 8 times more dense than water, and copper is 9 times. So we find that all 3 of these guys, if you were to put it in water, would sink all the way down to the bottom. Ethanol would, for a while, be on top, and then it would begin to mix together with water. So, what is the density of water? And this is very important. It is 1 gram per milliliter. What is the significance of this? Well, however many grams you have, that is how many milliliters you have. So if you have 50 grams of it, guess what? You have 50 milliliters. If you have 300 milliliters, you have 300 grams. If you drink a bottle of water that is 500 milliliters, how many more grams will you weigh? Well, once you drink it, you will weigh 500 more grams. 500. Because however many milliliters it is, that's how many grams. if your recipe called for 60 grams of water, how many milliliters would that be? Easy. Because the density of water is 1 gram per milliliter, it would be 60 milliliters. So, for just water, this works only for water. However many grams you have, that's how many milliliters. In chemistry, it will be very useful to be able to convert from one unit to the other, from grams to milliliters, and from milliliters to grams. That is why it is important for me to teach you density. So what is the formula for density again? It is density is equal to mass over volume. D is equal to M over V. Let me share with you the great triangle of science, 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 science. So, D, M over V. And the way you can remember this is that mountains are over deserts and valleys. Mountains are over deserts and valleys. If you, when you do these questions, can always recreate that chart on your paper, you too can solve these problems. They're not that hard. All right, so what is mass again? It is a measure of how much matter an object has. A measure of how much matter is in that object. And how's it different from weight? Well, weight is the measure of the gravitational pull that affects an object. So you can have a mass of, let's say, 75 kilograms, okay? But you go up into space and you may have a mass now, a weight now of only a few kilograms. Why? Because there's just not much gravity pulling down on you. The instrument that you're going to be using for measuring weight is a spring scale. Those are the ones that you go up to in your homes and you stand on them. And what it's measuring is the force of gravity acting upon your body, pulling you down. So it is measuring how much force gravity is affecting you by. So that instrument is going to measure your weight, the weight of an object. But the problem with weight is that it can change depending on how far you are from the center of the earth. The farther away you are, the less you weigh. So if you were to go up to Klingman's Dome, yes, you would weigh a few ounces less. Why is mass better? Because mass cancels out gravity. It is a comparison of you, the unknown mass, to masses that are known. You are comparing known stuff to unknown stuff. The instrument that we will use is the balance scale. Now imagine going up to your doctor's office, and in many doctor's offices they still have these kinds of scales where you stand on a square, and what happens is you see these bars with different weights upon them, and the nurse is going to move the weights over from left to right until the bar balances perfectly. That means that the nurse is comparing your pull, your gravitational pull, to the gravitational pull of those weights. So once you have an equal amount of weight on that one side, on the bars, to what you are, then that is your mass. Your weight is being compared to weights of known masses. So you have less weight on the moon, but you will have the same mass. That would be a mass scale. That's an ancient one. So what they would do in ancient times is they would take the object that you want to weigh, and then they would add little weights to this side until it balanced out. So when you have 30 grams here and it balances with this unknown object here, then it too must be 30 grams. So you are comparing the two. Comparing the two. In modern times, we have these electronic balance scales, and they are used to, basically they're programmed with what it feels like to, let's say, have 100 grams on it. So what they do is they know what 100 grams feels like. Once you put something else on there, they compare that something else to the 100 grams, and it gives you that comparison. Volume is how much space an object takes up. It is measured using a graduated cylinder in chemistry or a measuring cup in the real world. Can we depend on volume always? No, because volume can change with temperature. That is a graduated cylinder. Examples of things whose volume changes with temperature: frozen water and liquid water. As you heat it up, the frozen water expands. It changes its volume. Its volume gets bigger. Slabs of concrete. That's why as you're walking down sidewalk, you're going to see these man-made separators between the blocks, the blocks of concrete. They are there so that when it gets really hot, the concrete has some space to expand into.
Density. Just like all matter, water has physical properties that can be measured and calculated. To find the mass of water, you need a beaker and a scale. First, find the mass of the empty beaker. Then, fill the beaker up with your desired amount of water. Next, use the scale to find the mass of the filled beaker. To find the mass of just the water, we need to subtract the mass of the empty beaker from the full beaker. Our sample is 100 grams. The volume of water can be measured using a graduated cylinder. Our sample is 100 milliliters. Density is calculated by dividing the mass by the volume. Plug in your measured mass. We measured ours to be 100 grams. Divide that by the measured volume. Our volume was 100 milliliters. Water's density is 1 gram per milliliter. Objects with a density greater than 1 will sink when placed in water. Objects with a density of less than 1 will float when placed in water. If a block has a density of 0.1, it will float because its density is less than 1. Another block with a density of 0.5 will also float because its density is less than 1. Notice that more of the block was below the waterline. Another block with a density of 0.9 is also less dense than water, so it will float. We can see that as density increases, more of the block is below the waterline. Scientists have discovered that the block's density tells us exactly where the block will come to rest. If the density is 0.1, then 10% will be below the waterline. To calculate where a block will come to rest, just convert density to a percent. Density also explains why ice floats. If you freeze water, it expands. Let's use the black dots to represent the atoms in water. When you freeze water, no new atoms are added to the water. So because of the expansion, there is more room between the atoms. Compared to the atoms in liquid water, the atoms in the ice are not as tightly packed together, causing the ice to float. So try calculating density for yourself. It's mass divided by volume.
All right, so let's try doing it. What is the great triangle of science? Mountains over deserts and valleys. Mountains over deserts and valleys. Let's do it. Solve the following density problems. A piece of lead has a mass of 22.7 grams. So what I'm going to do is I'm going to draw my triangle. Mountains over deserts and valleys. If I'm given a piece of information, I'm going to circle it on the triangle. So 227 grams, grams is mass. It occupies a volume of 2.00 cc. cc is the same thing as saying milliliters. That's volume. Volume. What is the density? What I want you to do is what they're looking for, scratch it away. Scratch it away. And then what is left over tells you what to do. Take your mass and divide it by your volume. cc is the same thing as milliliters. So, calculate with me. 22.7 divided by 2.0 gives you 11.35, and these units go with you, grams divided by milliliters. This is an understood one. Now, I just like to have one decimal place, so I'm going to round the 3 up to a 4. So 11.4 grams per milliliter. That's it. That's all you do. You use your great triangle of science. But let's practice some more. A piece of copper has a mass. Mountains over deserts and valleys. A piece of mass. There they gave us mass. It occupies a volume. What is the density? Scratch away density. There it is. Mass over volume. 26.8 grams divided by 3.0 milliliters. Take out your calculators. Let's calculate together. 26.8 divided by 3.0. 8.93, but you can't round up. The 3 is too small to round that up. So I'm just going to keep it 8.9 grams per milliliter. Grams per milliliter. All right, let's get a little more difficult. The Great Pyramid of Science. Mountains over deserts and valleys. A piece of lead occupies a volume. Circle volume. What is the mass? They're looking for mass. Remember, its density is 11.4 grams. What's left? D and V. D times V is what you have to do. 11.4 grams divided by milliliters times 4.0 milliliters. Notice that in algebra, the numerator, if you have the same thing in the numerator as you have in the denominator, you can cross them out. So this leaves you an answer in grams. So, calculator, 11.4 times 4.0, 45.6 grams. So in 4 milliliters of lead, you have 45.6 grams. Does that seem like a lot? Well, yeah, because it is a very dense material. How about this one? It's a density question. Mountains over deserts and valleys. A piece of copper occupies a volume of 4 milliliters. Circle volume. What is the mass? Scratch away. Oops, that was wrong. Don't scratch that away. Scratch away the mass because that is what you're trying to find. I got to get my pen back. Hold on. All right. And they give you density. So it's D times V. Density, 8.93 grams per milliliter times 4.0 milliliters. Milliliters crosses out. Calculate with me. 8.93 times 4.0. 35.72. How about just 35.7 grams? All right, there are only 3 types of problems that we can do. We have now done 2 of them. In review, we've done the one where I give you the mass and volume and ask you to find density, and we have done the one in which I give you density and volume and ask you to find mass. Can you guess what the final one is? A piece of lead has a mass of 302 grams. All right. Mountains over deserts and valleys. So mass. What is the volume? Scratch away volume. Remember, its density is 11.4 grams per milliliter. So what's left? M over D. 302 grams over 11.4 grams per milliliter. And algebraically, that means that the milliliter needs to be on top here. You don't have to understand that in order to still be very good at this. You just need to remember that volume is always in milliliters. So the grams cross out. All we're left with is dividing. 302 divided by 11.4. 26.49 milliliters, which we can round up to 26.5 milliliters. One more example and then we're done. Mountains over deserts and valleys. Mass. They want volume. They're giving you density. So it's M over D. 200 grams over 8.93 equals, calculate with me, 200 divided by 8.93. Let's round that up. And remember that volume is in milliliters. All right, there's just 3 types of problems. I've taught you how to do all 3 types using the great pyramid of science. So, just some facts for you. Gold is the most dense solid. It's 19.3 grams per milliliter. While mercury is the most dense liquid that we know. It is 13.55 grams per milliliter. Rank the phases of matter in terms of the most dense to the least dense. Well, for most substances, it's going to be solid is the most dense, then liquid, then gas. But God made water to be very, very strange. In water, the liquid is the most dense, then the solid, then the gas. Why is that so strange? Well, water's the only one that I can think of that can do that. Why is that so important? Because think about it. If lakes and ponds were to freeze, where do they freeze? They freeze at the surface first. So the ice will float on the water, allowing little fishies and the plants to survive underneath. If water was like every other substance, it would freeze first at the bottom, freezing all the plants that fishes require in order to live. So life in the pond or in the lake would cease to exist. Oh, wow. Yep. You see this this giant iceberg where what's going on? A lot of it is up here, some of it is down there. If water wasn't strange, all of it would be underneath. How does the density of water cause erosion in nature? Well, think about it. Rainwater is going to seep into cracks when it's wintertime. Then, overnight, the water is going to freeze and expand out. Water is so powerful that when it expands, it can actually destroy everything around it. So as it expands, it pulverizes the rocks around the crack, making the crack even bigger. Then more rain can get in, more water can freeze, more cracking until finally that rock comes down. And we see a lot of that going on in the Smoky Mountains, and those roads that lead across the Smoky Mountains are oftentimes being closed because of rock slides. Guess what causes the rock slides? Expanding water. Why is this so important? Because by taking rocks and pulverizing it into smaller substances, that will actually find its way back into the water and give water the minerals it needs in order to feed plants and animals. Here's an example of how powerful water is.
The ice bomb illustrates the fact that the volume of ice is greater than the volume of an equal mass of liquid water.
So they're going to take this metallic grenade and fill it up with water. Oops.
The ice bomb illustrates the fact that the volume of ice is greater than the volume of an equal mass of liquid water.
All the way to the top.
Some cold water is poured into a cast iron bomb, and a threaded plug is screwed into the bomb so that the bomb is tightly sealed.
Then you're going to tightly seal it. Now this is steel. Steel bomb. You know how powerful that can be. Notice
the bomb is then placed into a dry ice
is.
acetone slush, which is at negative 77 degrees Celsius, and will cause the water inside the bomb to freeze.
So the water freezes,
a wooden
and
box
this
is
guy
placed
better
over the
get
top
out
of
of
the
the way.
bomb and slush bath. It takes a short time for the water to freeze. When it does, the bomb explodes.
Wow, a
Some
water
of the dry
bomb.
ice acetone slush is blown onto the explosion shield.
The water froze,
Little bits of the cast iron bomb are
but it
left.
had nowhere to go.
When the water
because it was
freezes,
completely
tremendous
full.
pressure is produced.
So
The pressure
it
is enough to
blew
cause this
up
cast iron bomb
the
with more than
steel
1/8 inch
grenade.
thick sides.
We're done.